Example 1. If a line intersects the side AB and AC of triangle ABC at D and E respectively and is parallel to BC, prove that AD by AB is equal to AE by AC. For these kind of problem, you have to write what is given first, then what to prove. Then only you can start the proof. So, what is given here? When you write the answer, it is not necessary to draw the figure, but if you are doing any construction on the figure, you have to draw, otherwise no need. So, given things, if a line intersects the sides AB and AC of triangle ABC at D and E respectively and is parallel to BC, what is given as DE is parallel to BC. What you have to prove is AD by AB is equal to AE by AC. To prove AD by AB is equal to AE by AC. DE is parallel to BC. DE is parallel to BC means here we can apply the BPT. If a line drawn parallel to one side of a triangle to intersect the other two sides at distinct points, then the sides are in proportion. So, the proof is this: since DE is parallel to BC, we can write AD by DB is equal to AE by EC using BPT. When you apply the theorem BPT, you have to specify there. So, AD by DB is equal to AE by EC, but what we need is AD by the total length AB is equal to AE by the total length AC. It is AC. To prove AD by AB is equal to AE by AC. So, DE is parallel to BC. So, AD by DB is equal to AE by EC using BPT. What you have to write first is take the reciprocal of this. Take the reciprocal of this, add 1 here, add 1 on both sides. So, DB by AD plus 1 is equal to EC by AE plus 1. Take the LCM, AD is the LCM. So, DB plus AD. Here AE is the LCM, EC plus AE. So, what about DB plus AD? DB plus AD is the total length AB. So, AB by AD is equal to, and EC plus AE is the total length AC. AC by AE. Again take the reciprocal. So, AD by AB is equal to AE by AC. This is the required result. Actually, we are taking this as a result to do the problems. The relation is AD by AB is equal to AE by AC. So, instead of using BPT, AD by AB is equal to AE by AC. We are using this result to do the problems. Example 2. The question is, ABCD is a trapezium with AB parallel to CD. E and F are points on non-parallel sides AD and BC respectively, such that EF is parallel to AB also. We have to show that AE by ED is equal to BF by FC. See, it is given that AB, given things, AB parallel to DC and EF parallel to AB. This means that AB parallel to DC parallel to EF, using the result, two lines which are parallel to the same line are parallel to each other. AB parallel to DC and EF parallel to AB implies AB parallel to DC parallel to EF. The reason is, two lines which are parallel to the same line are parallel to each other. And what we have to prove? To prove AE by ED is equal to BF by FC. Here we need to make a construction on the figure. You have to draw a line AC touching EF at G. Draw AC touching EF at G. Draw AC touching EF at G. After this, consider the triangle ADC. Consider triangle ADC in which EG is parallel to DC. So, this triangle ADC in which EG parallel to DC. So, we can apply BPT here. So, when you apply BPT, we are getting AE by ED is equal to AG by GC, equation 1. Then consider another triangle ABC. Consider triangle ABC. Consider triangle ABC in which GF is parallel to AB. So we can write AG by GC is equal to BF by FC using BPT. Equation 2. So, AE by ED is equal to AG by GC, and here AG by GC is equal to BF by FC. This implies that AE by ED is equal to BF by FC. This is the required result. So, here what we have done is AB is parallel to EF and which is parallel to CD. So, all these three lines are parallel. Then we have drawn a line AC, and then we have considered this triangle ADC in which EG parallel to CD. So, AE by ED is equal to AG by GC, and second triangle AG by GC is equal to BF by FC. Combining these 1 and 2, we can write AE by ED is equal to BF by FC. This is the final answer. Then example 3. In figure, PS by SQ is equal to PT by TR and angle PST is equal to angle PRQ. Prove that PQR is an isosceles triangle. So, given things, PS by SQ is equal to PT by TR, and angle PST is equal to angle PRQ. What to prove? To prove PQR, triangle PQR is an isosceles triangle. This is the given things. Given PS by SQ is equal to PT by TR and angle PST is equal to angle PRQ. To prove triangle PQR is an isosceles triangle. For proving triangle PQR is an isosceles triangle, what we are proving here is the base angles are equal. Using the first equation, PS by SQ is equal to PT by TR, we can say that ST is parallel to QR. Using one, we can say ST is parallel to QR using converse of BPT. If the sides are proportional, we can say these two lines are parallel using converse of BPT. So, if these two are parallel, so if ST is parallel to QR, we can say that these two are corresponding angles and they are equal. We can say angle PST and angle SQR are equal using corresponding angles. Angle PST is equal to angle PQR using corresponding angles. Mark this as 2 and this as 3. Using 2 and 3, we can say angle PQR is equal to angle PRQ. Using 2 and 3, we can say angle PQR is equal to angle PRQ. So, if these two angles are equal, we can say these two sides are equal using the sides opposite to equal angles. This implies that PQ is equal to PR. So, the final answer is, or final conclusion is, PQR is an isosceles triangle. Let's explain this once again. What is given as PS by SQ is equal to PT by TR and angle PST is equal to angle PRQ. We have taken this as 1 and 2. We have to prove that PQR is an isosceles triangle. From the first one, we can conclude that ST is parallel to QR using converse of BPT. If these two are parallel, we can say these two angles are equal, or angle PST is equal to angle PQR using corresponding angles. And mark this as 3. From 2 and 3, we can conclude that angle PQR is equal to angle PRQ. If these two angles are equal, the side opposite to these two angles are also equal, that is PQ is equal to PR. So, we can conclude that PQR is an isosceles triangle.